Okay, moving on to Theorem 3.10. Theorem 3.10 says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Now remember, complementary means they add up to 90 degrees. Now this one sounds kind of weird, but it's probably the most obvious of these theorems. If you have these two lines, so line AB and line BC, those are two sides of two acute angles. This is angle 1's acute and angle 2 is acute. So if those two sides are perpendicular, that means that the angles themselves are complementary. They add up to 90. That makes sense. Those two together would add up to 90 degrees. All right, so we are going to do a proof. You guys are experts at proof at this point. So what's the first step in our proof? The given. ED is perpendicular to EF. I like to get this out of the way. One, given. Okay, so I like to draw a picture. You guys can draw a picture here. We have ray ED and ray EF and angles 7 and 8. Now these are just the names of the angles. These are not the measurements. The measurement isn't 7 degrees and 8 degrees. Okay? And it's saying that ED and EF are perpendicular. Okay, so in this proof, we want to start to introduce some things, and our goal is to say that 7 and 8 are complementary. So what should we do next? Well, the first thing that we can talk about is from perpendicular. What does that mean? What does it mean about perpendicular? We can say that angle DEF is a right angle. Why? It's a definition of perpendicular. It means that DEF is a right angle. And what can we say about right angles? What do we know about right angles? That the measure of angle DEF equals 90 degrees. All right, so now we've established all the information we can out of them being perpendicular. Now we're trying to figure out that measure of angle 7 and the measure of angle 8 are complementary. We want to figure out that 7 and 8 are complementary. So let's maybe introduce 7 and 8 to the party. What can we say about the measure of angle 7 and the measure of angle 8? Well, based on this picture, pretty much all we can say is that those two angles together make up DEF. So the measure of angle DEF equals the measure of angle 7 plus the measure of angle 8. Now, what's that postulate that says that if we add two of the smaller angles together, we get the bigger angle? Angle addition postulate. All right, so we've gotten that from the angle addition postulate. And I want to say that 7 and 8 are complementary. That's the goal. So I want to know that 7 and 8 together are complementary, meaning they add up to 90. Well, what's the measure of angle DEF? It's 90. Do you guys see what we can do here? I have the measure of angle DEF is 90, And the measure of angle DEF is also measure of angle 7 plus the measure of angle 8. So we could say that the measure of angle 7 plus the measure of angle 8, instead of saying DEF, we can say it's 90 degrees. We can call that substitution. The reason it's substitution and not transitive is because we're just replacing one little thing. We're doing like a 1-for-1 switch, as opposed to transitive where it's like multiple things. All right. So we just established that the measure of angle 7 plus the measure of angle 8 equals 90. What does that mean? That means that 7 and 8 are complementary. They're complementary. Why? Why does them adding up to 90 mean that they're complementary? Well, because that's the definition. Definition of complementary angles. All right, so you guys just proved that theorem. We just proved that if you have two rays that are part of acute angles, they're adjacent and they're perpendicular, then they're complementary.